did for yesterday?
Yeah, it basically will wind up doing all of the 7.1 section.
Can we do that? Just
Oh, yeah, that's good. All right,
so I'm not even behind?
not particularly. They're doing half of it yesterday, half of it.
So I just have to do all of them.
What is the atmosphere?
It's over the flat earth.
Yeah, it's only over that part of the earth that's still flat. Yeah, the atmosphere is, what does it consist of?
Air,
Helium.
nitrogen,
And Little Douglas was right, but where we live, that was flat as a foot.
Exactly. Right, so the main ingredient of the atmosphere is, I heard it, nitrogen. It is what percent? Nitrogen?
72.
Is 70, which one is right? 70, 72, 78, 73?
78.
It's 78%. 78% nitrogen. What about oxygen?
21%.
All right, about 21% oxygen. And what about carbon dioxide, somebody other than Cody?
4%.
4%.
It says carbon dioxide about 0.03%.
0.03. That's more like it. All right. What is ozone?
The thing that protects the earth from the UV rays.
Right. So what is it made of?
Gases.
Which gas?
Usually.
Helium, isn't it?
Not helium.
Oxygen.
Oxygen. Yes. So we use one type of oxygen. Why don't you put that computer down so you can follow along with this a little better? We use a type of oxygen called O2. We can breathe that and work with it. And there's another type of oxygen, ozone, and that's O3.
Why can't we just breathe the ozone too?
Our bodies can't use it.
It's all oxygen.
Well, unfortunately, kind of no.
Did anyone ever go up to the ozone layer?
You can
try-
get poisoned by ozone, by too much ozone. It is a thing.
Okay, so
I've read an article in some
Well,
chemical
well,
politics.
let's see.
I think they used. We are we're
is that why they call it the
196.
ozone layer?
So what?
Is that why they call it the ozone layer?
Right, ozone is actually holds off a little higher.
I thought that's where we were yesterday.
Yeah, well, we're kind of about stuff. But the 207 is where the questions are for today. All right. So we talked about these two words as well. The homosphere and the heterosphere. All right. Which is the part that we live in? Chris. We live in the homosphere. That's right. It's called the homosphere
Why is it called the homosphere?
because all the air gets mixed together and becomes kind of one big soup. And homo means together or the same. Right? So we're all, it's just kind of one, it's pretty nearly the same in the homosphere. And it's the very bottom layer, and it contains which other layer? Remember, we split the atmosphere into two sections. So the homosphere,
and stratosphere.
you're close. So the homosphere, oopsie, homo,
Heterosphere.
that's the heterosphere up here.
Mesosphere.
Well, that's in there. So the homosphere
The frigid layer.
contains the troposphere. All right. The troposphere is where weather happens and all the things. So the homosphere contains the troposphere. That's the inside layer. And then after that, we have the heterosphere. And now we get into all the other layers. All right. So the heterosphere basically contains all the other layers. Went through some of them.
Which one does the weather?
Troposphere. All right. All right, so down here this is where we have, we're not going to do that right now. troposphere. Then our next layer up is called the stratosphere. Right? The stratosphere. Can anybody tell me about the stratosphere? We talked about it a little bit yesterday. What happens to a cloud when it hits the stratosphere?
It just gets chopped off.
Just gets blown straight off the top. Right? So you have a big old fluffy cloud, tower cloud, and it hits the stratosphere up here and just gets blown straight off the top.
No more cloud.
No, it just gets flattened out on top, and you get what you call have you seen an anvil, a big old thunderstorm? It's a big old, we call it an anvil shape on a thunderhead. I'm not sure if you get them much around here, but whenever we had mine when we were in Wisconsin, Midwest often gets violent thunderstorms, and you get these kind of clouds a lot.
Does
This
it
big
flood
old
a
rain
lot?
cloud goes straight up and then just chopped off the top, flat.
Did it always really need it?
Pretty much. Yep. It's a very distinct change.
So how high does it go before the clouds just can't go anything? Like how high is that?
Yeah, about 7 miles.
So it says right here, it says jet fighters above the clouds. So they're over 7 miles up. So you don't want to fall out.
Well, I mean, people have. Well, so like, you remember Felix Baumgartner?
No.
Who was the guy who dived out of that balloon in the inner space?
Oh,
The
yeah.
We talked
sky.
about him, the skydiver.
Without a
Yeah, parachute. We didn't complete it. He was close, but we didn't complete it. He had to have a spacesuit because it was so hot. He had to have oxygen. He still passed out, falling down because he couldn't control himself.
Did he die?
He jumped out on this diagram here on page 201. You look at this. He jumped out from, I think he was like 75 miles or something. He was
So where the
he
balloon?
was like
He
through
could
the,
have been hit by me.
So he could have been hit by a meteor. Because 75 miles up.
maybe it wasn't quite that high.
It was like-
He was, they call it the edge of space, but when they say the edge of space, they're talking about a really, really wide region. And that's the trick.
But no, but if he passed out, then you couldn't have pulled the thing for
Oh, he woke up later.
Let's see.
Oh,
How did he win? Why did he pass
Like,
out?
you can
Like,
watch.
he would have been
I
struck.
don't know if he was
by
tumbling too hard, too fast or something, I can't remember.
Yeah, he
Too
was
many
going
Gs.
like.
I would not want to.
He broke the sound barrier. He was going faster than the speed of sound.
Oh my
He was
word.
going like, yeah, he was going.
So that means he was dropping over 700 miles an hour.
So he said 75 miles or how?
Once he hit the Earth's atmosphere, how fast did he go?
He slowed down. Maybe he was up at the,
You slowed on it.
so terminal velocity for a human, this is outside the range of our discussion today, but we're going to talk about it anyway. There's something called terminal velocity, and that means that's as fast as something can fall. So there's a certain limit that something can't fall any faster. Like a feather has a terminal velocity like 4 miles an hour or whatever. A person's human's terminal velocity is, I can't remember. It's like 98 or something miles an hour. So once you're going faster than that, it doesn't really matter. You're not gonna, I mean, once you hit that speed, you can't go any faster than that. It's just that's how fast you're gonna fall. So that means that after 14 stories high, I think you can hit terminal velocity. After that distance, 14 stories or 150 doesn't matter.
You're so gonna fall
You're
down.
same. You're hit the ground going the same speed.
Of
Of course, some people are denser than others, and that might make a difference.
How fast will the elephant go?
Roughly the same,
Yeah.
because the density of an elephant is about the same as the density of a human.
Isn't that one guy who took a piece of paper?
A really big human.
Yeah.
No, the density is the same. It just means
Didn't he take one
we
guy?
really are deep.
The one guy dropped a rock and a piece of paper off
Yes.
the thing, and they hit at the same time. Something like that. It was something
Something
really like.
lost the
As long
feathers.
as,
Yeah,
as long as you
or
like shape them
something.
the same.
But
Yeah,
the
as long
rock
as
was-
they're shaped the same.
the
You
rock
don't
was-
have the same like you just.
The rock was a
No.
lot
It
heavier.
has to do with air resistance. So the thing is, if you take air out of it, you have a big tube, and you have a penny and a feather at the top.
The penny will fall faster.
Right. The penny falls faster. So you have a tube, you both on one end, flip them over, they'll fall the same speed. I mean, the penny will fall faster, hit the ground. That's because of air resistance. So what you do is you put a vacuum pump on here and suck all the air out. So there's no air inside here. Flip them over, they'll fall the same speed.
And if they don't?
They will fall because of gravity. They'll fall exactly the same speed.
All the way down.
Moving on to something completely different.
Then
We
how
talked
about
about the UVB, which is the one that suntans you and gives you skin cancer and things. And that is only partially absorbed by the ozone. Which UV is completely absorbed by the ozone?
UVC?
UVC is completely absorbed by the ozone, and UVA is not, because it doesn't matter. And God's like, yeah, whatever, let them have that, I guess.
Well,
All
he
right.
left no himself with that.
And then the mesosphere. The mesosphere was one of the. I don't really talk about this that much, but the
So-
mesosphere is the coldest layer of the atmosphere, and that's just after the stratosphere. So inside the stratosphere is the ozone, or kind of between the stratosphere and stratosphere and the ozone layer. It's kind of part of that.
It says like negative 150.
Negative 150.
Yes, you can.
So you, yeah, it is.
So, yeah. It says that, oh yeah, what was my question? It was, can you make UVC radiation without sun?
Oh, I'm sure. Probably a nuclear bomb. All right. So the mesopause. So this is so we have the stratosphere and then we have the mesosphere. Now remember that I said that as you go up away from the Earth, it gets colder.
Yeah.
1,000 feet you go up, it gets 3 degrees colder.
Yeah, so what about, what's this 3,000 degrees Fahrenheit up there?
We didn't talk about that. Well, we actually kind of did. Once you hit the stratosphere, it actually switches for a second. All right. Actually, let me talk about this first. So everything has an ending point, obviously. Every one of these spheres has a place where it ends as it goes up. And that is called, well, for the troposphere, we start at the troposphere, that's down next to the troposphere. That's down next to this, to the Earth. And then you get to this line where the troposphere ends, and that's called the tropopause. Which makes sense. It's where the troposphere pauses, and then it changes to the next layer. Then you get the stratosphere. And where the stratosphere ends, you get the stratopause. And then you get the mesosphere. And where the mesosphere ends, what do you get? The mesopause. Yes, exactly. Which makes sense. And it keeps going on that way. So that's just kind of the layer where it ends. The coldest layer in the atmosphere, the coldest place in the atmosphere, is where the mesosphere ends at the mesopause. What did it say? Negative 170? I think it
How
said
long did it
150?
take that guy to fall?
About 10 minutes.
So how long was it knocked down?
But if you can only go like, so if you can only go 98 miles an hour or whatever, then how was he going 700?
Because the air resistance was so low.
What do you mean you can only go 78?
Huh?
What do you mean you can only go 78?
You only, 98, like that's the terminal velocity. That's at sea level. Terminal velocity at sea level is like 98 or 100.
So
I
you,
can't remember which.
it's,
You can go faster than that at sea level.
Not falling.
Oh.
All right. So mesopause is the coldest area of the atmosphere.
I don't
Let us go ahead and
We can drive that.
check. Oh wait, you didn't do any of this first stuff. We'll check all this.
Well, how far did you do it up to?
We just we kind of picked and chose.
I
We
did-
finished the 7.1, and I will give you the quiz as well here.
So I did up to 5.
It's 6. Well, I think.
no, we just skipped 4. We skipped 4 and did 5 and 6. Okay, I didn't do 6, so.
Okay, we'll just finish it up, then we'll check it tomorrow. Thursday.
The coldest point in the
All right.
atmosphere is the mesosphere.
We're going to go on. No, the coldest point is the mesopause. The mesosphere is cold, yes, but it's the mesopause. It's the coldest. All right. So we got to the mesopause. The next layer is the thermosphere. Now thermo means heat. We can deal with that. We get our thermopause, and now we get hot. And it gets hot and it gets hot and it gets hotter. It says at the top of the thermosphere, near what we would call the thermopause, (3,000°F, which is hot enough to melt steel? Aluminum for sure. I think aluminum melts at 2100. It will just, so take your aluminum for the truck up there and you get a puddle. There's a puddle for the truck.
How hot do we have to be before we know? Like,
A lot less than that.
really?
A lot less
Well, I
than
mean,
that.
I know that, but like,
As long as 700 degrees you start burning.
Okay, but like not burning, but melting.
Melting, I haven't experimented with it. I'm not intending
You
to either.
experimented with burning?
Well, only bad things happen to good people.
Such as?
We'll just keep it moving. So, the thermosphere actually goes out about 300 miles. So this would be one of the places, well, yeah, like the International Space Station would actually be flying within the thermosphere. Yeah. Exactly. And the space shuttle is actually generally lower than that, or was. Most satellites are actually in the lower end of the thermosphere, so we're a little warmer after the mesopause.
so if somebody would fall out of the International Space Station, would it burn up? Or would it
No,
freeze?
they would just.
Well, they would just die.
Yeah. But would,
You wouldn't die from cold or heat first. You would die from, you would boil.
You would.
So the thing is, people have experiences like the oxygen suits. Bad things happen to good people. Oxygen, like the spacesuits spring leaks. Basically, what happens is like your mouth starts boiling away. Like you start losing a lot of water, evaporates out of you because of low pressure, which is a topic for another day. You want to avoid that. Your eyes start bubbling and carrying on, and like all the water tries to boil away from your body. And that between that and radiation from the sun, because you're above the UV layer protected, and extreme cold or heat, and just
there's a lot of
blowing up because there's not enough pressure. Something will kill you. That's what I'm saying.
Something's not going to tell you something else.
Okay,
Yeah,
but
something not gonna kill you. You can kill the sun.
okay, but if you were standing on the International Space Station, say, doing repairs or whatever you're doing, if you just let go for a little bit, what would happen? Just don't.
Well, usually that hooked up. Like,
Usually they're tied. All right.
Or
So
do
the
they have
thermosphere.
called jetpacks? That they
What,
use
so the
to
thermos,
fly?
it says many astronauts sent into space only travel in the thermosphere. It's because we kind of refer to the thermosphere as part of space. All right, and then beyond the thermosphere is the exosphere.
is it hot?
And that's just kind of, that's out there. And that is just space.
Is it hot or cold out there?
Well, it's not very dense, but it's cold generally. And that's a little hard thing to explain, but I'll try to do that another time. I hope to get into a kind of a spacey section later. All right, regions of the thermosphere. Molecules are heated by ultraviolet radiation, and you get something called an ion, plasma, which is, I'm sure some of you have seen plasma cutters. Steel is a plasma cutter. Or basically it's the fourth form of matter. So we know of matter as we have gas, and air is gas, and liquid, and the solids. And there's a fourth form called plasma. When you see flames of fire, that's plasma. That's actually a fourth form of matter. We don't tend to think about it. And because it's hard to explain. Basically, it's electrons flying around, and that's not going to worry about that too much. So basically, there's a place in the thermosphere called the ionosphere. And that just means there's ions flying around in there. And those ions, oh, I should have studied this part harder. I was trying to study a different spot. We're not going to worry too much about the layers. We're going to talk about the E's and the F's and all the things. Not going to worry about that too much. Basically, the thing I want you to remember is the ionosphere is something that you bounce radio waves off of. So if you want to, if you're talking to somebody on a long distance radio, you'll actually sometimes bounce radio waves off of it. Or like television or radio and stuff. You'll get like shortwave radios and AM stations, which are almost never found anymore. But they're actually bouncing radio waves off of the ionosphere. And there's the magnetosphere, which just uses the magnetic poles of the Earth, and well, I'll talk more about that another time. I'm not time today. Basically, I want you to read this and find the answers, and then we will talk about some of the rest of it. Atmospheric pressure is the last thing I want to mention here, and that means that it's basically the air weighs stuff. You know that when you pull up a fish from deep under the ocean, you know, if you pull up a deep sea fish, its eyeballs will pop out.
Never had that.
Never experienced that? Those are usually really, really deep sea fish. And the reason is because their internal pressure is geared to push out against all the pressure of all the millions of tons of water.
So this is like,
So you pull them out and their internal pressure blows their eyeballs out. All right? Kind of similar to what goes on here. We are down at the bottom of the Earth's atmosphere. All the weight of the Earth's atmosphere is on top of us. And we don't feel it. But for every square inch on top of your head is 14 pounds of air.
what if that was
We're going to
released?
column all the way to the top.
Would we just go
So-
flying off the earth? Like,
So what if you got a giant helium balloon or hydrogen balloon just went shooting up in the air? How far would you make it up before you exploded?
You wouldn't probably explode because your skin would probably hold everything together. Not unless it was an explosive decompression, but we're not terribly concerned about that.
You just get away from
What I'm saying is, for every square inch is 14.7 pounds pushing down on any object, even if you're inside. That's the atmospheric pressure. That is what we deal with. And you notice that when you go up a mountain, that pressure gets less. That's why your ears pop. It's the pressure from inside of you pushing out and making your ears pop, because as you go up the mountain, that air pressure gets less to make it 13 pounds. So that's what's going on there.
how far down did you go in there?
It holds you at about 10,000 feet.
So how much weight would you have on your
Yeah.
head? Like not 10? Or?
So then that's a pressurized canister, so it'd be like, 10-ish, 10 pounds.
Your ears
All right.
don't pop up there.
Yeah, they do. That's a fact.
Like when divers are way down in the sea and they come up really fast.
Then, yeah, exactly. Then you get the bends. All right. We have an experiment to do on Thursday. We're not going to do another experiment I was going to do today. We're not going to do it as well. I want you to finish one. I'll get you your quiz, do that, and hand it back to me. We'll check it. We'll check the rest of this work Thursday. I'll go over some of these things.
So
Oh, they have some. Well, no, just run this like a worksheet. Just hold on to this. Run it like a worksheet. Put it in your.
Can we do it?
do we not need to do the rest of it?
Yeah, do the rest of this too, but also do this as a worksheet.
Can we do that?
Yeah. You can go back.
So this is a quiz, basically.
Yeah, just treat it like a worksheet. Oh wait. Yes, sir.
8.
Okay, how is history?
Oh, we have a question about your checking.
Oh dear.
What was that first one?
D and A. I don't know why they did that. I didn't think I
Hey,
did
but
that.
it says E, yeah, what's wrong with
Maybe I did.
You took it
The
out.
committees and correspondence.
It says each numbered item was 2 points.
But see, then
And
you
see,
give us
one
another place.
item may have more than one unanswered. Maybe I kind of think that as it could either be A or D. I think it's like,
Oh. No, that could be, hang on a second, that's a good question.
We don't do the thought provokers, do we?
Yeah, I can adjust your grade for that.
That was on Algebra. How long do you want this outline to be? So, if I do wildlife,